before starting, I had some specific questions. So, do you know that your personal information can be useful for a third party? And for like, for example, some companies and some applications? And do you know where and how it is stored? So this is what will be specifically the talk of today. So I will cover the use of mobile edge computer in a distributed architecture and deployed in a mobile crowd sensing environment. So my name is Hanane Lamaazi. I'm a postdoctoral fellow at the Center for Cyber Physical System at Khalifa University in UAE. So my talks will be generally about introducing the concept of Internet of Things and crowd sensing, then highlighting the difference between centralized and distributed architecture, introducing the concept of edge computing, and concluding by one of our recent research and the recent proposed solution that we call OFSEC. So as we know that Internet of Things, it's an emerging technology that try to connect everyday objects to the internet. So it cover all domains of our lives, including healthcare, home automation, transportation, cybersecurity, and even industry. So here, as we can distinguish that by the IoT analytics that is done in 2020, that 1,414 projects deployed the Internet of Things concepts, where manufacturing and industrial are the most common one with 22%, followed by transportation and then by energy. So here, just to look to see the impact of including the Internet of Things in different domains and how they are competing to use this emerging technology. So as we say, Internet of Things, it's connecting everyday objects, which means that generating a set of a huge number of the data that it will be processed, filtered, and stored later. So crowd sensing, it's like a specific case or a subdomain of it's an enabled technology for Internet of Things that has as main objective is to collect the information or to collect the data by deploying a set of users, or what we call in crowd, the term used in crowd sensing, it's workers that use mobile devices, generally some smartphones and wearable devices, and executing some specific tasks while generating or collecting more information about a specific phenomenon. So there is two type of crowd sensing. The first one is the participatory crowd sensing, and the second one is the opportunistic one. So in participatory crowd sensing, the users volunteer to participate, while this is not the case for opportunistic. The data is sensed, collected, and shared automatically, and sometimes even without the knowledge of the user. With participatory, the user decide or determine how and when and what to sample and where to sample or to collect the data. While this is not the case for opportunistic, that gather a large amount of data that will be processed later on, but in a small time. It doesn't require too much time. So for participatory, avoid the phone issues, like, for example, application crash, bad battery life, and so on, like this kind of issue, which is not the case for opportunistic. Why? For example, if you use one of your application that you already install in your mobile phone, and when this application starts sensing or collecting your information, and your phone is turned off, so in this case the sensing process is stopped, because it is done without the knowledge of the users, and it is based on the phone conditions. Also, for participatory, it's more expensive or require a high cost than the opportunistic one, for the same reason, because in a participatory, as we say, that users, they volunteer to participate, while this is not the case for opportunistic one. And those users are sometimes paid for this kind of works, for collecting the information. For this reason, it is more expensive than opportunistic crowdsensing. So here, this is some example of mobile crowdsensing applications. Like, for example, the well-known YouTube, Facebook, Uber, Upwork, Instacart, and so on, that deploy a set of workers, and those workers are paid based on their job. So here, this difference in companies, IoT devices, technologies, this is what we call heterogeneous. So a heterogeneous environment is an environment that deploy different or diverse devices or transmission technologies. For example, there is some devices that can share, for example, we can share our pictures using, for example, Wi-Fi direct or Bluetooth, or even using Wi-Fi or 4G. And this is a different, completely different transmission technology. And also we can share our information using smartphone, as well as using computer, or for example, dash camera, camera of surveillance, and so on. So this diversity, this is what we call heterogeneous environments. So in this kind of environment, also the data is heterogeneous. Why? Because it depends on the device's conditions and the environment conditions, and also the transmission technology conditions. So the generated data, after being collected or sensed, it will be gathered and sent to a centralized platform. At this centralized platform, this data is stored and requires some additional computation and additional processing and filtering. So this centralized platform requires some or has some challenges or limitations. For example, the delay in answering real-time requirements, because as we say, we have a very big amount of data that is generated, a different data, a heterogeneous data that is also stored, and this kind of information need or require more time to be processed and to be ready to send to the end users. So it takes too much time to give a feedback to answer a specific request from a specific user. Another challenge is discovering the non-connected devices. So what we mean by non-connected devices, it's, for example, for smartphone or for other devices, we can use Wi-Fi or 4G communication network. In this case, those devices are accessible by the server and discovered by the server. While, for example, in case of sharing using Wi-Fi direct or Bluetooth communication, those devices can be hidden from the server. So this is one of the main limitation of a centralized platform. Also, they are complex on computing the data due to the volume of the data that is stored there and that is generated. And the last one is the high cost. They are very expensive. So the centralized platform are very expensive because for the same reasons, they require a strong memory to store the whole information, and also require a very high capacity of processing. So to overcome this, some of the limitation of the centralized platform, there is two solutions that was recently proposed The first one is using a decentralized or a distributed architecture. And this distributed architecture, as you can distinguish in these two figures, the first one, the whole information is sent to the cloud. So all the information, whatever the source, are sent to a centralized platform. While in the distributed architecture, the information is distributed according to the area of interest, according to the location of the server, and according to the location of the workers or the users itself. So here the information, instead of going to a centralized platform, it is distributed in different places or in different services. And this makes the processing of this data very easy and more fast than the case for a cloud or a centralized platform. So the second solution is the edge computing. So the edge computing is considered as enabler for IoT services that allow computing. That is an optimal solution for computing a large amount of data. So it's like it is used like an intermediate layer between the cloud server and the mobile users. So it is placed in between. So it allows to reduce the complexity of computation because it is placed near to the end users, and also it is responsible to do some data filtering, aggregation, processing, and storage, and respond in real time to the final users. So this edge computing has a set of benefits. The first one is the parallel and the partitioning problem space based on the location. As we said in the previous figures, that there is a set of edge servers, and each one of them collects a set of information that is situated in the same location, and those information are processed in parallel. So all the servers work and at the same time on the same, not same information, but on different information, but they are complementary information. And after that, after this computation, if, for example, the information or the request that is sent by the user, it's a very easy task, or it can be answered in a real time, the edge node is responsible to answer to that user. But in case if the user need more information, this the edge computer send the request to the cloud computing, and the response will be coming back from the cloud computing. But and for small task, the answer or the interaction between the edge server and the mobile user, it's direct. So another benefits. So this interaction or being placed near to the end user provide other benefits, like reducing or offloading the computation for both mobile devices and cloud server, reduce the computational complexity of a centralized cloud, and decrease the latency and the privacy threat. So for offloading computation, the edge computing, as we say, it's placed in intermediate between the mobile devices and cloud server. So, for example, in a mobile devices, if the data is collected, for example, if I'm using my smartphone and the data is collected, as we can know that a smartphone has a limited memory, storage memory, and a capacity of processing. So, for example, if I collect a very huge number of information, I cannot process it or compute it in my own smartphone. So what I do, I send it to the edge computer. This edge computer do this computation. So in this case, I offload the task that normally should be done in a smartphone. It is already done in the edge computer. And also, for example, if this task usually it is processed on a cloud computer, but in case of deploying edge computer, this task can be treated locally into each computer without even going to the cloud and getting a feedback from the cloud. So it's like a double benefit, offloading the smartphone and also offloading the cloud servers. And for the latency, this is for sure near to the end users. So it's mean that there is a fast answer or fast reply to a specific request. It means that's a low latency. For the privacy threats, for example, if all the information, and this is the case of centralized platform, if all the information is stored on a cloud or a centralized platform, for example, in case of attacks or, for example, material destroyed or crash or something like this, all the information will be lost. But in case of distributed architecture, the information is distributed in different places. And for example, if some of this information is missing, so based on what's still as information in the other servers, we can, for example, predict what is missing, or we can estimate or expect the missed information. So and this is what reduce or increase reduce the privacy threats. So here, based on what we learned about crowd sensing, about the limitation of centralized platform, and about the benefit of each computer and our sensors, we try to deploy or to make like a combination of all these concepts in one architecture. So we proposed a OffSec solution, which is a edge computer-based solution that deploy edge nodes, different entities of edge nodes, and it's a distributed architecture that deploy a set of servers, a set of edge nodes, and select a set of workers, which is the third concept. It's deployed in a crowd sensing environment for worker selection or worker recruitment. So here I will show you. So here our solution addresses the following concepts. First, the resource discovery, because what we assume that our architectures not only deploy the connected devices, the devices that use Wi-Fi or 4G or 5G, in general wireless communications, but also it can discover other non-connected devices, for example, that deploy the Bluetooth. So because our solution aims to integrate the concept of heterogeneous environments. So here we use a different technology. Also, it's a task allocation because it's based on the task received from the server or the worker also, because we assume also that the task can be initiated by the different entities, maybe a response to a request from an edge server, or for example, for an event detection, it will be initiated by the workers. It's a context where, because it's based on what we have in the environment, what we have in terms of IoT devices, the connected and the non-connected devices, also the number of participants or number of workers available on an area of interest, their location, the location of task, and so on. So all this kind of requirements should be considered, are considered in our solution. Also, heterogeneous worker selection. So heterogeneous IoT devices and heterogeneous wireless or transmission technology lead us to address the concept of heterogeneous workers. And finally, the budget constraints. Why we introduce the concept of budget here? Because this is the one of the main parameters of crowd sensing. So crowd sensing deploy first a set of workers, mobile devices, as we say, smartphone or wearable devices, and in case of participatory crowd sensing, we need a specific budget because the workers that are recruited in this kind of crowd sensing, they are already paid. So it's according to the budget that we assume or that we attribute to each edge node. The selection will be stopped. If, for example, that budget is reached, so we stop the recruitment. But if it is not the case, we keep recruitment for sure. So here, this is just a video that explains clearly how the solution works. Sorry. Okay, so as we can see here, the final task is the worker selection. It's attributed to each LAN or local edge node in each cluster. So based on two parameters, which are the quality of services provided by each worker. So each LAN or each local edge node select the best workers based on their quality of services, and also based on budget, because this is why we say that our solution it's a budget constraint. So according to available budget, we keep recruiting the workers. So as a results or finding, we found that our solution selects best workers, and based on that provide a very high quality of services, and the quality of services it include like a devices characteristic and also workers reputation. So the workers selected by our solution have a high reputation compared to the centralized one, and also the information or the data collected from those workers it's more consistent. So as a takeaway, all what we need to know is that mobile crowd sensing it's a human-driven paradigm that has as a main focus is collecting the data from a physical environment using a mobile devices, and a centralized mobile crowd sensing it's suffer from a set of limitations that can be overcome by the deployment of mobile edge computing, and without forgetting the concept of heterogeneous environment, which is deploying a diverse entities or devices that have a different character and content. And if you want to connect and contact me, this is my LinkedIn, my Gmail, and Google Scholar and Scopus if you want to read some of my research. And thank you so much.